All right, 3.7, we're going to be talking about absolute value both in equations and in inequalities. So let's begin by something that you might already know. So what does the symbol for absolute value look like? Like two bars, right? Like x is trapped between two bars. Yeah, okay. So if I gave you the absolute value of x, let's say as an example, is equal to 5, what is the meaning behind this statement? What's the meaning behind the statement? Absolute value of x is equal to 5. What does that mean? Why do we even have that? What's the point? Think about it. Think about it. No idea? It exists for no reason whatsoever? Ah, there we go. It's a distance, right? It's the distance from 0 on the number line, right? We're talking about locations, okay? So on the number line, if I give you 0 here, and I give you, 5 is over here, and I give you -5 is over here, -6, so on and so forth, 6, put a 4 here, put the -4. I have all these numbers on the number line. What does this mean? The absolute value of x is 5. What does that mean? What does it look like? How do I visually represent it on the number line? Yeah, Jay.
Wouldn't you put like wouldn't you say it's a distance between 5 and 0?
Yeah. So I could put a number here, right?
Yeah.
Or where else could it be? It could be here, all right? Why are these the two locations it could be? Because the distance from here to here is 5 units. That's what that means. And the distance from here to here is also 5 units, okay? So when we say the absolute value of x is equal to 5, that means that we have two locations, right? There are two locations that it could be. It could be here at -5, or it could be here at +5. So when we say the absolute value of x is equal, is equal to the number 5, what we're really saying is that x could either be 5 or, there's the or statement, x could be -5. Right? So there are two locations, right? Doesn't it make sense now to talk about absolute value right after we talk about compound inequalities? Because we have two possible locations in or statement. Okay? So it could be 5, it could be -5. Okay. What about this statement here? What if I gave you this statement? The absolute value of x is now equal to -5. If I gave you that statement right there, what's the meaning behind that one? Take the same discussion that we just did. What's the meaning behind it? Is this the same as the last one? Some say yes, some say no. But it's saying the distance is -5 units. Does that ever make sense to us? No, I wasn't trying to trick you. It wasn't a trick question, but it's something that we should talk about, okay? When we have the absolute value of a number is equal to -5, we can stop right here and say that this is not possible. Okay? The absolute value represents a distance. We never ever say a distance is negative. Like if I say, hey, how far is it from here to Irvine? You go, -42 miles. That doesn't make any sense whatsoever. Okay? So when we're talking about absolute value, in terms of what it actually means, we're talking about distances. Distances are always positive. Now, there is a dot above the -5, but I'm not saying that the absolute value is -5. That's not possible to say. Does that make sense? There's a clear definition between the two, okay? Okay, the first thing that we learn how to do is solve absolute value equations. And we want to get the absolute value by itself. So this right here is the absolute value. It's the stuff that's trapped between the bars, all right? Notice that there are some operations that are going, I'm taking 3 times that number, and then I'm also adding 12. So I need to undo everything to get the absolute value bars by itself before we can actually solve this, okay? So what would my first step be? I would subtract 12 from both sides. So let me erase these circles for you so you can see. Let's subtract 12 over here. Let's subtract 12 over here. So I get in 3 times the absolute value of 2x plus 9 is worth -2. Now what? All right, let's divide by 3. I'm with you. I'm still with you. Divide by 3, divide by 3. So I'm saying the absolute value of the quantity 2x plus 9 is now worth -2/3. Now what? Yes?
Subtract by 9.
Nope, I don't subtract by 9. Remember that conversation we just had?
Oh.
The absolute value of stuff is equal to negative, and we said it was not possible. So look what we have. We have the absolute value of stuff is equal to something negative.
Multiply by -3/2.
No. No, it's just not possible. Yeah, we can stop right here. We can stop, right? No need to go any further because this particular absolute value equation has no solution. And you know what? It is possible for equations to not have solutions. Now, a lot of time in Algebra 1, the problems that we do in the book and the problems that we contrive from word problems, they're all very solvable. They will turn out nice and neat. But that's not always the case, right? It does not have to be nice and neat every single time. The answer does not always have to be 1 or 2 or 5 or -8. Sometimes there is no solution, right? Sometimes there are problems out there that cannot be solved. And there are many of those, and that's just part of real life, so it's also part of algebra. It's not really talked about a lot in a lot of classes, though, but I want to make sure that we have an understanding. So if we're solving an absolute value equation, and we isolate the absolute value, and it's set equal to something negative, we fundamentally interpret that as there is no answer, there's no solution, because it doesn't make sense in the meaning of the context of the problem. Does that make sense? All right, sweet, awesome. All right, let's see if we can solve this one. The absolute value of an x minus 10 is equal to -2. All right, we want to solve this and we want to graph this thing, right? All right, so what should I do first? If I want to isolate the absolute value bars. Yes, absolutely. I would add 10 to both sides. I would add 10 to both sides. So I'm getting the absolute value of x is now equal to -2 plus 10. How much is that worth? That's worth 8. Okay, now we have a solvable absolute value equation. All right, so what are my two possible locations for this if I was going to graph this? Yeah, you got it. Here's 0. This would be -8, and this would be +8. So I could either be at 0.8 or I could be at -8. So in this case, x could either be 8 or x could either be -8. These are my two solutions. So on the graph, I would put just two little dots above 8 and above -8. All right, an absolute value inequality is a little bit different than the absolute value equation, right? Just like before, when we solved equations that had answers, we'd say, okay, the answer is 5, or the answer is 6, or the answer is -8. But when we have an inequality, we have a range of answers, right? The answers could be any x that's bigger than 7, or any x that's less than -9, or something that's between two sets. So whenever we talk about absolute value equations, then we need to also talk about absolute value inequalities. So let's begin by taking another example of what would this mean if I gave you the absolute value of x is strictly less than 5. Okay? What does that mean graphically on the number line? The distance from where is less than 5? The distance from 0 has to be less than 5. Well, how many distances is that? Is that 1, 2, or a lot? It's a lot. It's a lot, right? Okay, so this fundamentally means this, okay? If I'm on the number line, all right, I want all x values that are smaller than 5 units away from 0. All numbers that are smaller than 5 units away from 0. That's what this means. So if I'm over at 5 and I'm over here at -5, all right, then I'm going to have an open dot here at 5 and an open dot at +5, and I want all values of x that are a distance that are less than 5 units away from 0. So, could this number work? Could -3 work? Yeah, because the distance between -3 and 0 is a value of 3 units, and that's less than 5 units, so that works. What about this number over here? What about 4? Does that work? Yeah. That also works, right? Because 4 is 4 units away from 0, and 4 is less than 5, so that also works. Okay, now, how do we deal with an absolute value inequality? Well, the answer is actually on the page. Take a look at that red segment of a line that I have written for you, and write for me a compound inequality. This is an and statement, correct? So what is this saying? All numbers that are between what and what? -5, 5. How do I write that as an inequality? Very good.
Less than x,
Mm-hmm.
which is less than 5.
Absolutely perfect. So look, we have now just realized that that statement The absolute value of x is less than 5 means negative 5 is less than x is less than 5. That's what it means graphically, right? So notice that our compound inequality below there written in purple does not have absolute value symbols in it, right? Because we understand the meaning behind it. So in general, if I have the absolute value of a is less than b, then I can automatically turn this into this. Negative b is less than a, which is less than b. And this is how we deal with an absolute value inequality that is less than. All right? Now, I could have also had less than or equal to as well. That also works. So if I also did less than or equal to, then those would also be less than or equal to as well. All right? So notice absolute value of a less than b, then we can automatically write the compound inequality negative b less than a less than b. And that's the reason why, right? People don't know. Have you ever solved an absolute value inequality before? No? Maybe? Somewhat? Think maybe? Okay, good. All right, well, that's good. We're still dealing with this. Now, let me give you the next part of the story here. What if I gave you the absolute value of x was greater than 5? Okay, well, let's see if we can figure out what does that mean. Well, on the graph, what are we interested in? We're interested in all the values of x that are more than 5 units away from where? 0. So give me a number that's more than 5 units away from 0. 6, give me another one. 7, give me another one. 42, give me another one. 27, give me a negative one. Negative 65, negative 10, right? How many answers are there possible? A lot. When there are a lot of answers, we use inequality notation as sets. Okay, so on the number line, let's check this out. Here's what this means. Here's 0, here's 5, here's negative 5. Well, I want all values of x that are more than 5 units away from 0. So all of these values will work for me. Okay, now all you have to do is write down a compound inequality of the graph that you see. So how can I write down a compound inequality of this? It's an OR statement. Yes, very good. It's an OR statement, so how do I do it? X is less than negative 5, or x is greater than 5. Absolutely. So let's take this. So notice when I have the absolute value inequality that is greater than, I make an OR statement. And this is the reason why, because we want values of x that are more than a certain distance away from 0. So in general, if I have this, if I have the absolute value of a is greater than b, how do I deal with it? What two compound inequalities can I write? It's written for you right there on the page.
So it'd be a is less than negative b.
Negative b, or a is greater than positive b. Very good. And that's how we deal with it. All right? And that's the reason why we deal with it. Now, it could also be greater than or equal to. All right? So this right here, this is the heart of the lesson in this part. This one over here and this one over here. What do you think the most common mistake that students make is in this particular case? What do you think is the most common mistake? Yes, Daniel, they switch the two, right? They set up a less than statement as a greater than statement, or vice versa. Okay, that's the biggest mistake, is that they mess them up like that, all right? So right now we're going to practice this to make sure that we don't do that. Okay, here we go. The absolute value of 8x is greater than or equal to 24. All right. So what kind of a statement do I have? Do I have a greater than statement, or do I have a less than statement? I have a greater than or equal to. So if I go back up here, how do I deal with a greater than or equal to? What does that say right there? No, that's a greater than. So I set up a compound inequality with the word or. That's what I do. So here's what we do. I say, okay, either this means that 8x is less than or equal to negative 24, or this means that 8x is greater than or equal to 24. That's what that means. That's the meaning behind the absolute value inequality. Do you see the relationship of what we did? Of why we did that way? Okay, so now I just simply solve both of them. All right, I'm going to divide by 8 on both sides. So I'm going to get x is now less than or equal to negative 24 divided by a positive 8. How much is that worth, you guys? That's worth negative 3. Very good. Or I'm going to divide both sides by 8. Divide both sides by 8. I'm going to get x is greater than or equal to what? Positive 3. So on my statement here, right, on my graph, I'm going to have 0. I'm going to have positive 3. I'm going to have negative 3. I'm going to have closed dots above each of them because they are both included. And I'm going to shade to the right of 3 and to the left of negative 3. So if I pick any one of those x values that's in either less than negative 3 or greater than 3, it should make that absolute value inequality true. Let's actually do that, okay? Give me a value that's less than negative 3. Negative 5. Good, so this would be negative 5. So let's test it. If I bring this back up here and I look, the absolute value of 8 times negative 5, is that greater than or equal to 24? Well, how much is 8 times negative 5? That's negative 40. So I want the absolute value of negative 40. Is that greater than or equal to 24? What is the absolute value of negative 40? It means 40 units away. So 40 units is greater than or equal to 24 units. So yes, it makes that statement true. Do you see how that works out? Now, which one would not be true? Give me one that would not be true. And we'll do this one in red for us here. 2. 2 is located right there. It does not fall in our interval. So let's take 2 and let's test it out and see if this works out. So let me move this over and shrink it down a little bit. So I'm going to have this. The absolute value of 8 times 2 needs to be greater than or equal to 24. How much is 8 times 2? So the absolute value of 16 greater than or equal to 24. The absolute value of 16 means 16 units. So 16 is greater than or equal to 24. Is that a true statement or a false statement? That's false. 16-year-olds are not older than 24-year-olds. That is not true. So therefore, our picture verifies our algebra. Okay, we're going to solve and graph this. Absolute value of 2x minus 1 is less than or equal to 9. Okay, if it's a less than statement, then my compound inequality will be joined by the word and. Very good. So I'm going to have my compound inequality. It's going to say this. Negative 9 will be less than or equal to 2x minus 1 will be less than or equal to positive 9. I have a compound inequality joined by the word and. That's how we set it up. Okay, so what do I do here? How do I get my x by itself? Same idea. Let's add 1 everywhere, right? Let's add 1, let's add 1, let's add 1 everywhere. So negative 9 plus a 1, that's worth negative 8. So that's less than or equal to 2x. That's less than or equal to 9, and 1 is worth 10. Good. If I move up a little bit, I have this. So what do I want to do now? Divide by 2 everywhere. Very good. Divide by 2, divide by 2, divide by 2. So negative 4 is less than or equal to x values, which is strictly less than or equal to 5. Good. Can you think of numbers that are between negative 4 and positive 5? Sure. There's a bunch of them, right? All those are. We can easily do that. So we could represent that on the number line as such. So give me 0, give me negative 4, give me 5, give me 2 dots. Let's color both of them in because they're both less than or equal to. Let's put a line between and let's shade in that region. So any x value that picked in that region will satisfy the original absolute value inequality. 2x minus 1 is less than or equal to 9.